Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 6th, 2025, about 3 days ago. The big idea is an adaptive sampling method that reallocates rollouts toward uncertain prompts, which stabilizes reinforced style training and delivers higher final scores than group relative policy optimization, with weighted average gains of about 1.1 to 3.6 points. The paper is titled Reinforce ADA, an adaptive sampling framework for reinforced style LLM training. And as we will see later, the implications for model training are quite significant. Beyond accuracy, the approach speeds convergence, improves pass at small budgets, and shifts the reward entropy trade-off outward with modest extra compute. Also, the authors shared the official code on GitHub. You will find a Python implementation that integrates adaptive sampling into the Variance trainer with clear setup instructions, data preparation utilities, and scripts to train and evaluate. The README explains key flags like multi-round adaptive downsampling and reinforced ADA choice, and it covers VLLM integration and reproducible runs. Alright, the previous segment covered the code release. Figure 1 presents the plug-and-play idea. A simple swap in the generation call enables adaptive, multi-round downsampling. The left panel illustrates the one-line API change, which keeps the rest of training untouched. The right panel plots reward and entropy over steps, showing faster reward growth, a higher final reward, and healthier entropy compared with group relative policy optimization. Okay, the previous figure showed plug-and-play gains. Figure 2 illustrates why small uniform groups lose signal because they often yield uniform rewards. The left panel charts pass at K rising as attempts increase for both a base model and its reinforcement learning checkpoint. The right panel plots the share of prompts with all correct responses, which falls sharply as K grows. The contrast implies that larger K reveals true variability, albeit with higher compute cost. So the previous figure highlighted why uniform groups lose signal. Figure 3 presents reward versus training steps across 4 backbones, and the adaptive variants consistently rise faster and finish higher than group relative policy optimization. The balanced version leads in each panel, which suggests better sample efficiency because it preserves diversity while filtering weak prompts. The advantage appears within the first 50 to 150 steps and persists through convergence. The curves are smoothed with a moving average. So the previous figure showed faster reward growth. Figure 4 contrasts reward against entropy and then reports pass at K. The left and middle panels show an outward shift of the reward entropy frontier, which means higher reward at the same randomness level and higher entropy at the same reward. The balanced variant leads because exposure to both wins and losses keeps policy diversity. The right panel converts that stability into stronger pass at K, especially for small budgets up to 8. Alright, the previous figure contrasted reward and entropy. Table 1 reports held out accuracy using average at 32 across 4 backbones and several math suites. The adaptive approach improves the weighted average by about 1 to 4 points, with the balanced variant leading in every backbone. Gains appear on Math 500, Minerva Math, Olympiad Bench, and the AIM E-like set, and the hard training splits benefit most because adaptive sampling keeps informative prompts active. 2 takeaways stand out. Adaptive sampling that reallocates rollouts toward uncertain prompts prevents uniform reward collapse and yields higher rewards, and pass at small K with only about 2 to 3 times more compute. The plug-and-play swap means easier adoption across trainers. The broader implication is clear. Variance-aware data curation makes reinforcement learning for reasoning models more reliable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.